at the end. So, all right, this is chapter 5 about TCP/IP. I guess I can do it full screen. I can get out if I need to. So, come on, come on. Oh. Last week, you noticed part of the recorders weren't all up there real quickly. They turned this machine off, and I hadn't copied all of them off of it. And then I kept calling Saturday to have them come turn the machine back on, and no one did. So I came up there Sunday morning, turned the machine on, and get the files off it. That's why part of the recordings weren't up there until Sunday afternoon. So, but
I did get an email where all the assignments were updated.
I changed the zoo times to 5:40.
Do that.
To give him a hard
syllabus is out.
Yeah. Syllabus doesn't say the time.
It does.
It should, shouldn't it?
Well, then there's that.
All right, talk about chapter 5, TCP/IP. A lot of vulnerabilities in it. Okay, I use an example in quite a few of my classes. If you were to take a 7-Eleven, y'all know what a 7-Eleven is. If you were to take a 7-Eleven, convert it to a bank, how good of a bank would that be?
Joke.
Yeah, because it wasn't built for security. It was built to sell ICs. That's what TCP/IP is. It was not built for security. So trying to secure IPv4 is like converting a 7-Eleven to a bank. I mean, it's not there, okay? What it is a suite of protocols. So it's the TCP/IP suite. It says many protocols, many applications. It's common language. Has anyone ever worked with any other protocols like IPX, SPX? Anybody? Jim's probably seen it. Anybody? You don't notice that was actually much faster. That was much faster. NetBUoy was good, but on small networks. AppleTalk, I don't think ever really got anywhere. But they came upon TCP/IP. Now, did anyone configure TCP/IP back with Windows Workstation 3.51? It was back when it was like Super TCP for Windows. Came on like 7 disks, and it was SLIP at that point instead of PPP. So you had to answer like 200 questions to get it to work, and it was sucked. Nowadays, it's just there. So it's changed a lot. A lot of things are getting in the way. They start off really rough, and now they get much easier, okay? But it allows us to transfer files, surf the internet, and do pretty much anything, okay? It says IP has tools that correctly route, I didn't spell it. I didn't miss the E, they did. That route packets, which would be nice to get the packets to go where they're supposed to go, okay? And is responsible for safe and reliable delivery. Okay, we're going to talk more about that. Okay. It says, illegitimate users take advantage of the vulnerability because it's like the 7-Eleven thing. People know it's not a good bank, so why would you do it? Well, TCP/IP has a lot of problems. People know about it, then they exploit them. Okay. All right. There's the 3-way handshake, which we're going to see. There's all kinds of stuff they can do. There's denial of service. I think it was eBay and Yahoo got hit by denial of service a few years back. Was those the two big ones? Got taken down for a while, but when I worked at an ISP downtown, we had our provider was Cox, and we sold T1, we sold ISDN, we sold dial-up and all this stuff back in the early 90s. Well, we had one client, which was a mother and son, who had way too much money. They didn't work. They were literally just on the internet all day long. They had a T1 through us, which is back then was very expensive. It was like $1,800 a month. Well, they would spend all day long on chat channels and all this. Remember IRC and all that? And they would just make people mad. Well, they did something to this one person, and they basically denied service against that. But the problem was, since we were their provider, it really hit us. So we had to have Cox come out at like 3 in the morning with their laptops. We ended up blocking like 16 separate Class C networks just to the point where we could get our network to work again. It was terrible. They were hitting us so bad we were dead in the water. So it's bad. I thought and then later on I got my own ISP at my house, and I actually thought I was getting a denial of service attack one time. My network traffic went from very minimal to massive amounts of traffic. They used up all my bandwidth. Well, what it turned out was Bart Connors, the gymnast, I hosted their website, and they'd go to competitions, and they would do it live from the competition. And they had millions of subscribers that would be updating the page every 5 seconds. And then I about freaked out. I'm like, what is going on? And then I saw they were all for his website. I sent him a nice note. Yeah, Would have been nice if I'd known you were going to be streaming to the entire world. But you know, that's kind of what it is. They kill your computer. Okay? Floods it with so many additional requests that regular traffic is slowed or completely interrupted. Okay? All right, here's kind of what it looks like. Okay? They have the original OSI model. We really don't use that. The OSI model is kind of like an idea that we all, yeah, this looks like it'll work, but when it was actually implemented, it really didn't follow it. It was actually modified somewhat to the TCP model, the 4-layer model. But we're going to talk a whole bunch more about all the different stuff. You can see all the applications like at the bottom. HTTP, which is, anybody know what that is? HTTP, hopefully you all know what that is. Web browser, hypertext transfer protocol. We got file transfer protocol, telnet finger, secure shell, DNS, BGP, POP3. What's POP3, anybody? Email. Post Office Protocol 3, okay. SNMP, anybody know what that is? That was Simple Network Management Protocol. It was funny. Yeah. When I was up at University of Tulsa, I learned there's some things you don't say to Dr. Shinoy because he gets very mad. Well, you know, I was complaining about one of the lectures because I have these Friday night lectures. The different cybercore students would lecture on different topics each week. Well, this one guy he was an older guy. He's graduating at the end of that semester and he's going to talk about networking. And he goes in there and says, yes, you know when you're checking your email, you use the SNMP protocol? I'm like, what? I said, no, it's SMTP when you're checking the email. And so I asked Dr. Shinoy about that. He's like, well, we don't cover that in our program. And he's very smart and all that. So basically he yelled at me and I like, you really shouldn't talk bad about it. So I never made that mistake again. So you know how that goes. But it was funny. I still remember that to this day. But there's a lot of different applications that we all use. Now some of them, like Gopher, really don't use it much anymore. It's kind of like search. That's what it was. Finger is not used much anymore. SSL, secure socket layer, obviously is. We use that all the time. Time services. Everything works off time nowadays. And you know, I was doing something on a phone that was unplugged for a very long period of time. The battery was dead. And I couldn't get it to do something. I forget what it was. It was an iPhone. But I didn't realize that someone had set the time to manual. And I couldn't check mail. I couldn't check anything because the darn clock was off on the phone. It's like, it can really cause big issues. Okay. We have two main protocols in the middle there, TCP and UDP, Transmissions Control Protocol, and I can't think of the word. User Datagram Protocol. I couldn't think of the name. But we're going to talk more about those here in a minute. Okay, then we got ARP, which we actually talked about already, didn't we, in this class? Yeah, this class was the last class. And IP, Internet Protocol, and a bunch of other stuff. So there's lots of different stuff out there. So they talk about encapsulation. We're taking our data and encapsulating it kind of like in packages. Okay? Also called data hiding. When you look at the packages going on the internet, most of the packets are more overhead than their actual data. So there's actually a lot of stuff out there, okay? And if you learn about encapsulation in Java, it's the same kind of thing. You want to hide how it works. A prime example of that is I have a Chevy Volt in the parking lot, the electric car. Do I know how that car works? No, I know I turn it on and I can drive it. But do I know the actual functionality of it? No. You know, I remember when cars had like carburetors and that kind of stuff way back when? You actually you knew what the whole car did. You could work on it. I mean, nowadays, no. I mean, my Prius, the other day, my gas gauge wasn't working. It wasn't, but you ever have a gas gauge that's like full, then all of a sudden it drops down to like below a quarter? Just had to be adjusted. I found on YouTube somewhere, it's like, put it on trip A, then turn it off, then turn it back on, hold the odometer button for 5 seconds so it blinks twice, and hit this button twice, and hit this one, and wait for it to blink 6 times, and it reset it. I'm like, holy moly. So there was a lot of functionality there I didn't know about. The same with here. We don't want people to really know all the data. They just want it to work. Okay? You ever seen those users nowadays that they just want it to work? Yeah, that's what most of them are. They're like, you just got to make it work. It's like, well, okay. All right. So we're basically taking the data and encapsulating it, or putting packaging on it to get it to the point where we can send it across the network. Then we're unpacking it. Think of it just like sending someone a package. You take your stuff, you put it in some packing paper, put it in a box, you put a label on it, you tape it all up, you send it through the mail system, gets to the other end, they open the box, they take out the stuff, and then same way. Same way with packaging here. All right, IP, it says transmits data from source to final destination, okay? It says it's connectionless, okay? IP doesn't care if it gets there or not, okay? IP, you got TCP and IP, okay? IP is the connectionless. You can think of it as an idiot protocol. You got TCP and IP. Think of it like the mailman, okay? And you got the mailman and the addressing. Does the addressing really make sure it gets there? So if you address a letter correctly, does that guarantee it's going to get to your house? No, it's still someone has to deliver it to your house. So IP is more of the addressing, okay? But it's it's connectionless. It says no guarantee of delivery of packets. Is that address right? It just didn't make it. You ever get wrong mail at your house? I get it all the time, okay? And for the longest time, there was like I'm at 8412, and there's like an 8214. They swapped two of the numbers. Same street, just down over the hill a little bit. And I'd get packages for this guy all the time. And I'd walk him up to his house all the time. And I got tired of it. So I called UPS one day. They're like, sir, couldn't you just carry it? I said, no, I've been carrying it to his house forever. You need to come back out here, pick up the package, drive it 5 houses up. Because I kept delivering it for him. They weren't delivering correctly. And I tell you, since that day, I've never had a package for that guy.
Your delivery man had a substance abuse problem?
I don't know. It was always, and we got a different delivery man after that. It's kind of funny because I had a brand new gutter system put on my house when I had a roof put on. And he had a brand new truck, and he backed right into my gutter. I mean, it was like a week old. So he called me and goes, Ken, this is my UPS guy. I just ran into your house. He goes, I smashed your gutter. He goes, don't tell anybody. He goes, get it fixed. I will pay you cash money. Don't call anybody. Don't tell anybody. I'm like, okay. So since it was brand new, I still had the guy who did it. He came out, it was like $150. UPS guy came over, paid me $150. He goes, don't call insurance. Don't call anybody. I'm like, okay. So, but yeah, it was weird, I realized the amount of packages they delivered, but that guy kept delivering the same package or the same 2 addresses screwed up every time. It's terrible. Okay. All right. IP addressing. We have IPv4 and IPv6. Okay. IPv4 is a 32-bit address. Okay. Usually dotted decimal, 192, 168, so on and so forth. There's, if you figured the 6.5 billion people in the world, there's about 0.66 addresses per person, which is not a lot. But remember when we started this whole internet thing, wow, one computer was plenty for an entire office. Okay? IPv6 is a 128-bit addressing scheme. It's written in hex. And there's 50 octillion addresses per person, approximately. I don't know about you, but 50 octillion addresses is probably plenty for me. I mean, we're talking every blade of grass, every speck of dust in my house could have an IP address on it now. But it's getting to the point where more and more stuff is going that way. Did anyone ever look at Iris? You ever heard of Iris yet? They sell it at Lowe's. It's kind of like a home automation system that pretty much does everything. They were at CES this year, and it looks pretty good. I have a lot of stuff automated in my house now, but that goes way above and beyond. It has like flower pot sensors. You can literally put them in your flower pots, and it can tell your IP-enabled watering system to water the flowers. It's like, seriously? It's way above and beyond. So it's pretty cool. But we're going to get to the point where we need something like that. Okay, we're going to need more addressing, and IPv6 is being used today. But like Rose State does not use it internally. I'm assuming nobody here uses it internally at home. You might have it enabled, but you probably don't use it. It's there. Actually, a lot of machines it's on by default. We just don't use it. Rose State specifically blocks it because they don't want to manage it yet. So, okay. All right. IP addresses ran out in 2011. There are no more. So what does that mean? Does that mean the internet's dead? Obviously not. It's functioned fine since 2011. All that means is no more addresses to give out. Okay? But, you know, Cox, for instance, Cox has plenty of addresses. When I originally got my ISP, I was looking to, you know, get service from somebody. And I wanted quite a few addresses. So I contacted Logix. And they were $750 a month. And Cox was $900 a month. So who do you go with? Logix is cheaper. But Logix wanted to charge me $5 per IP address. And I wanted at least 32 addresses. Cox is like, oh, whatever you want. So what do you mean? They're like, yeah, if you need more, we'll just give you one. They're free. No big deal. So, because Cox already owns them, so they just assigned me a block of this. So I ended up going with Cox. But, you know, there's lots of addresses already out there. Internally, though, it doesn't matter. Like Rose State. We all surf the internet here at Rose State. And, you know, if you ever go to like a Rose State computer and you type in IP chicken, just easy to remember. IP chicken. Any computer on campus with the exception of the cyber lab. It's the same address. So every computer on Rose State's campus with the exception of my labs is on that same address. Because we're basically hiding behind a firewall, and to the outside world we see one computer. Internally we see however many there are, hundreds, thousands, I don't know anymore. Okay? So, you know, we really don't need it. Okay? If you want to get your own IPv6 address, I think it's Horizon. See if this is him.
That looks like it's right.
Huh?
Electric.
Yeah, it should be Horizon Electric, isn't it? Search for it. No, HorizonElectric.net, I think. Is this them? No, there should be Horizon
It'll be a
Electric.
black and white screen with looks like an oil well with a lightning strike on top of it, I believe.
No. Is that them? Oh, I can't remember their darn name. Technology. It's an IPv6 tunnel provider. IPv6. Hurricane Electric. That's what it is. Not Horizon. Hurricane Electric. Hurricane Electric is actually an IPv6 tunnel provider that you can get an address for free. And you can configure it on your router, and you can start using IPv6 today. So, yeah, it's up there if you want to play with it. It's just totally free. Okay? It's a free IPv6 tunnel broker. Okay? I was planning on, in all my labs upstairs, going strictly to IPv6. But Rose State is not implementing it yet, and so I still have to go out through Rose State. We would have an issue with that, so that's why I haven't converted mine. So. But yeah, if you want to look more about it, it's Hurricane Electric that you can read about it. All right, so addresses are gone, but there's still plenty of them out there. Okay, it says IP packets arrive out of sequence. Happens all the time. But since they do come out of sequence, there's vulnerabilities based on that, which we'll talk more about. Okay? And when packets are sent, they're actually fragmented. Y'all remember this? That's like Windows disk fragmenter thing. I used to do the beta testing for Diskkeeper, the one who made this. And it was kind of cool because you got the free software. And I actually found a bug in their software once where it came up and said, volume corrupt, restore backup. What does that mean? Well, it was funny because I contacted them, told them I found this bug. And they started FedExing over me cookies and stuff. I'm like, okay. Well, they found a bug and they needed to figure out what it was. So they were being very nice to me, sending me all this stuff so I could keep trying to help them figure out what the problem was. Well, it turned out it was an old version of McAfee that was running with their current version of software were not compatible. So the way they fixed it in the README file is this: if you get the error about blah, 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 disregard. What the heck does that mean? They didn't fix nothing. They just put in documentation that I disregard. Because my machine was fine. It's just that it was reporting incorrectly. But so what they do is they break up the packets. You know, a good example of that I always tell in Intro to Networks is kind of like you go to the grocery store. Can you imagine one big huge bag with everything in it? You drop that bag and got it shopping all over again. If you break it into smaller bags, oh, you drop the bag with eggs in it, well, you only got to replace the eggs. You don't have to worry about the bread and everything else. So you break it into fragments. That's what they do with packets over the internet. Okay? And this is the header, the IP header. There's a lot of stuff in here. Version, length, type of service. A type of service is one that's kind of weird. It's also known as DSCP, which is Differential Services Code Point and Explicit Congestion Notification. I don't know how they got that in the type of service, but that's what it is. I have total length, time lived, which we can talk about in a second. We have source and destination addressing. You'll see that's a 32-bit address. We have a header checksum. This actually changed in IPv6 the way checksum works. But there's a lot of information about it. Now, like version, okay, it's a 4 bits. Say it normally holds 6 or 4, so you know which version it is. The length, the type of service, like I mentioned. Now, I put this on there. I captured some traffic in my office today. Remember here we talked about time to live? See on the left there? What time to live is, imagine a packet getting lost on the internet. Would be a bad thing if it just kept cruising around forever? Would be. So what they did was they put a time to live address on it. And every time the packet goes through a router, it's decremented by 1. So if I start off with a time to live of 128, after I go through 128 routers, it's going to read 0, and then it's going to be deleted. So it's a way of getting rid of the bogus packets out there. Okay? But the way it starts is different. Different operating, there's tons of different operating systems. I just put a few of them up there. Different operating systems start with a different time to live. Okay? So, looking at this Wireshark capture, which I did this afternoon, I'm looking at the top picture right here. IPv4, my time to live is 128. Y'all see that? It's right in here. Okay, everybody see that? It's my time to live. Don't we have a pen in here or something? Can I write maybe? Let's go with highlight. Okay, my time to live is 128. So based on just that alone, which operating system was I running?
Windows.
Alright, so just by looking at the packet and the time to live, I can enumerate the operating system just by that alone. Isn't that kind of scary? I mean, just by the packet you can say, oh, obviously 128 is Windows. Alright, so now, let's look at the next one. This is actually the reply from whoever the heck I was contacting. That time to live is 50. Right there, see it? Time to live 50. So what operating system is that?
You don't know. We don't know.
No, without knowing how many hops it took.
Right, but I can make a guess.
Right.
I can say the odds are it didn't count down from 128. The odds are it probably counted down from 64. So I'm assuming it's a Linux version. But at least it gives me a good idea where to start. So just by looking at one packet, I can at least get an idea of what I'm working with here. Okay? So kind of a cool thing, yes.
Does that depend on how far they were?
Exactly. I don't remember who I contacted when I did this. I was probably Google or somebody. I don't know who it was. But it's the packet coming back from them. Because I sent them a packet. When they replied back, how many routers did it have to go to get from them to me? And I would say it was about 14.
So if they were in Europe, it might be 4.
Yeah and no. Because there's high-speed backbones of the internet that kind of like skip, like from Florida, I think basically to Oklahoma. So sometimes you can get across the country quicker than you can get next door. It's like for a while there, I would do a test to my home network. And from Rose State to Choctaw Road, I went through St. Louis and Dallas and everywhere else. It's like, what the heck? Because it's where every provider goes. But it's kind of one of those deals, here you can't go anywhere without going through Dallas or something. Yet I can fly halfway across the country once I get to Dallas. So it's...
And satellite will throw it all over
Yes.
the place too.
Yes. So, and for a while there I had an Atlink Wi-Fi. I don't know if you ever heard of them. They're a Wi-Fi wireless company, which before all I had was DSL, which was good compared to dial-up. But Atlink Wi-Fi could give me T1 speeds for like $45 a month. It was really, but it's all wireless. But they actually had a router on my roof at the antenna then another router at the same location, which then I connected to. Because I tried to set up a static IP address and I couldn't. I had to pay them extra because they actually had, you know how you got a cable modem? Well, they actually had 2 of them up at their end. And then my router. So it was actually 3 routers just to get into my house. It was like, it was weird the way I had it set up. But I love their service. It was great. But now that I have Cox, obviously this is faster. But the issue I had with theirs was there was a couple Sundays I'm out there, so my internet goes dead. Totally gone. And I'm like, what the heck is going on? So I called them like, oh, hold on a second. Then they come back. All of a sudden my internet comes on. I'm like, oh, we didn't know anybody was using that frequency. You just randomly turn off frequencies without checking if anyone's using it. A couple different weeks that happened because I was paying a little bit extra for the higher speed, for the static IP, so I was on a different frequency. And they just randomly turn them off. I'm like, seriously? But it was good service, but Cox is faster. But so TTL, time to live, is a very important thing, but it kind of gives it away as well. And if you search for default time to live on the internet, there's like actually let me do that real quick.
You ever get Fios, it's much faster.
Yeah.
Fios, if they, I don't know, the Verizon will get.
Once you go on Netflix, and then it's really slow.
Exactly.
Okay, there's some there, but where's that bigger list?
Slow anyway, isn't it?
Okay.
Same what they have up in Kansas.
I don't know if Verizon's there, but it's fiber optic.
Oh, come on, there was a great, huge list I found earlier today.
In Kansas, that's super fast.
Well, we have a Google fiber, went up
That
to
might
the city,
be. Oh, yeah, that's
and
it.
then it's going to Austin next.
Companies like Knowledge, they have fiber optic in Tennessee.
Yeah, AT&T's basically rolling out fiber anywhere that Google's going, like following right behind them.
I don't know where the darn list was. It was this huge list, but it's on the internet somewhere. Okay, but point is, you can find it if you want. There's just lots of information. Okay, so they talk about all the different stuff here. You know, like there's time to live. Like I said, specifies the maximum time the datagram can remain on the network, stated in terms of how many router hops it will take. Okay. We got header checksum, which is kind of an error checking thing. That's actually one of the changes between IPv4 and IPv6. IPv4 has a header checksum and a data checksum, so it's basically we're checking it multiple times. IPv6's thought process was, why check it multiple times? Because if the whole packet's good, it's all good. So IPv6, let's just check the whole packet rather than check individual pieces, which kind of makes sense. So, you know, there's a lot of changes. And there's source addressing, 32-bit. Obviously, IPv6 is 128-bit now. So there's our source address, our destination address, different options and different padding and stuff like that. Okay? All right, so TCP, a connection-oriented protocol. This is the one that actually makes sure it gets there. Okay? So it says participants in the session must create a connection. Kind of like me calling you. Okay? UDP was connection, or IP was connectionless. It was like, actually UDP as well. You don't care if they're listening. But TCP is like me calling Brandon. Hey, Brandon, you there? And he's going to say, yeah, this is Brandon. And then, you know, we're basically making a three-way connection, which we'll see in a second. Okay. So connection-oriented service between a source and destination computer. I want to really make sure it's you I'm talking to. Okay. All right. And it says packets reach the application layer in the right order, which helps. So it actually puts it all back together for us. Okay. They have what's called a sequence number here. Okay. An initial sequence, say 32-bit number. I don't know, did it show us on that other screen? Did it show ISN? I don't see it on. Oh, that's because that was an IP header. Duh. Okay. But what TCP, there's what's called an initial sequence number. It's a random 32-bit number that we start with. Okay. And then, you know, if me and Brandon are talking, every time I send a packet to Brandon, that number is incremented by 1. That's how we can put it back together, because it's all incremented by 1, which is kind of handy. Now, if you look at it inside Wireshark, see here on the screen it says sequence number is 1, right there in the middle. If it's a random 32-bit number, how could it be 1? Well, what it is, Wireshark has the option to use relative sequence numbers. You can see it on the right. Okay. What that means is Wireshark is smart enough to know, okay, this is the beginning of a conversation. So whatever that random number is 1. The next one's 2. The next one's 3. It actually throws you off when you first look at it. And it's like, I think you guys might have to worry about that in one of your assignments. I can't remember, we'll see. But yeah, so it's the random sequence number, and it's right there. It tells you, or it's the relative sequence number. But it's a random 32-bit number how it starts, or how it starts. Okay.
Is that, what's the default? Do you have to go in and change it to that, or is that?
Oh yeah, the default is 1.
Oh, it is, the relative is the default?
Yes, it is, which I did not like.
I don't like that either.
Because I was talking about this in one class. I'm like, yes, it's a random 2-bit number. And some guy goes, how come it's a number 1? I said, it's not. It wasn't. But if you actually look at the data of the packet, it wasn't a 1. And I was like, how the heck is it? Then I realized Wireshark is giving me a relative number based on the sequence in the conversation. Which is fine. It's just, I don't like that. But it's one of those things that it make it idiot-proof. Okay, the normal user's not going to have a clue what the huge number means. So let's just start with number 1. So, yeah. The default is right there. Relative sequence numbers checked.
Okay.
But it's under edit properties or edit preferences or something like that. So, yeah, I had to find that. Okay. So here's the TCP header. Now we got the source port, destination port. Now, what's the port for internet? Port 80. Port 80. SSL is 443. Now, so if I'm going to talk to Google, so I'm going to make a connection to Google on what port? 80. Are they going to answer me on port 80? No, they're not. They answer me on a port greater than 1024. Okay? So really, they listen on 80, but reply back on a different port. That's why source and destination will match. So if you ever filter out port 80, you're going to see a one-way conversation. You're like, okay, I keep talking to Google, but they're never answering me. Yeah, because they don't answer on the same port. They can't. It's kind of like this is the incoming line. The other one's the outgoing line. Okay, there's our acknowledgement number. Okay, there's some flags, and here's some issues with flags. Urgent, acknowledgement, push, reset, SYN, and FIN. Like urgent. Not that critical anymore. Remember back in the old dial-up days? Yeah, you had to have special things to make certain packets get there quicker. But nowadays, nah, you don't need. It's like, you know, I look at so many people's computer. You know how your browser has a history where it can keep a cache in there? It defaults to like 20 days. Does anyone actually still use that? Why do we keep that history now? I mean, our internet's fast enough. The only reason we had that way back when is because when we had dial-up, we went to whatever web page. We didn't want to have to re-download it every time we went there because it was taking up our bandwidth. But nowadays we have such fast internet. Let me look in here. I bet it's turned on my computer. Do we have that wonderful IE on this one? Did I not install IE? There it is. Internet Explorer. Okay. Let's go here.
That would have been when you had more static web pages too.
Right. Now they're all dynamic.
Right.
Okay. Under Internet Options, under Browser History right here, okay, we're remembering 20 days of data. It's like, why? Oh, no, that's 20 megs of space. Hold on. Oh, we're keeping 365 days of history. Why would I keep a year's history on this machine? Is that not like an issue? So, yeah, that's great. So we have 20 megs of space in a year's worth of history. Okay? And you know, I always check this. Delete browsing history on exit. Because I don't need it no more. Then I always go in here to mine. And I change this to 0. And I change this to 8 because it has to be at least 8. I don't know who came up with that stupid idea.
Can you drop the radio down to never?
But I still think you need 8. Watch. If I put in a 0, it's not going to like it. Warren, you must have 8. Yeah, I don't know why it does that. So you do that.
I guess that's your currently loaded page.
It could be, yeah. But what's that doing for me? Well, it's keeping less junk on my computer. It's just, it's not like Google takes long to load now anyway. I think that's back when we had MSN for a search engine, which actually had stuff on it. Google's empty, so. All right. But, all right. So let's go back to where we were. Okay, so some of the flags aren't needed anymore. It talks a little bit more about them here in a minute. Then we have our data, we have options and stuff like that. So there's some other stuff as well. Okay. The source number is 16, destination 16, sequence number is 30. That's what I told you, the random 32-bit number. So it's a very large number. Okay. Now we have an acknowledgement number. I'm talking to Brandon here. I talk to Brandon, he replies. Every time I send him a packet, my sequence number goes up. Every time, yeah, and he starts talking to me with a totally random number as well. So it's not that mine goes up by 1, then it goes up by 1 more when he answers. Mine only increments when I talk. His only increments when he talks. So there's 2 separate numbers, and we can keep them in order that way. Okay. All right, and there's our SYN and our FIN. I think they, yeah, okay. We'll talk about it in a second. We have window size. Window size is how much data can you handle at one time. Think of your kids. How many bags of groceries can they carry at one time? When they're young, maybe 1, or a part of 1. Then as they get older, they can carry more and more groceries. And you ever see the kids where they, like my son, my youngest, says, I can carry all of them at one time. And they grab and he drops something and he breaks something. So basically that was too much for his window size. He couldn't carry that much. So we had to decrease his window size. That's what Windows is. It starts off and sends a little more and a little more until it starts having some errors. And way back when we started getting faster modems, 56K modems, you could actually go into your computer, into the registry, and change the initial window size. Because it used to be set to really low. This is back in Windows 95 days, I think. But you could change it to a higher window size, because now we had high-speed modems. And what that would do is, instead of the computer having to slowly speed up, it automatically started fast. So that was one way it made your computer seem faster. I guess it was faster. All right, so we got SYN and FIN. That's the whole, creating a connection. We have their window size. There's our checksum. This is our second time we're checking our errors. There's an urgent pointer and some data stuff like that. Okay. Some of the flags: urgent, acknowledgement, push, reset, SYN. The ones that are important are SYN, FIN, and ACK. Okay. The way it works is I'm going to talk to Brandon here. I send him a SYN, synchronize packet. Okay. He receives it and sends me a SYN ACK. So he's acknowledging my SYN and sending with an ACK and sending me his SYN as well. His SYN as well. Then I send him back an ACK. So it's like SYN, ACK, ACK. So then we said it's kind of like, hello, is Brandon there? Yeah, this is Brandon. Oh, okay, let's talk. So that's our 3-way handshake. Now with SSL, it's actually a 5-way handshake. So we have to pass a certificate. The whole point of SSL is secure socket layer. We want to know, who are we really talking to? Am I really talking to my bank? So what they have to do is they have to send me their certificate so that I can verify with a certificate authority to realize that it really is First National Bank. So that's why it's a little more involved. So there's our SYN, our SYNAC, and our ACK, which I just mentioned. Okay? So connection setup says the source computer delivers a SYN packet with an initial sequence number. The SYN bit is set. Receiving computer transmits its own SYN and an acknowledgement. Then the source sends the acknowledgement again. And then within a range sequence, computers are set up to accept packets in a range. I don't know what the exact range is. But can you imagine if you would only accept packets in order and the packet got lost? Could be waiting for a while. It got out of order, so. Okay. All right, here's a picture of one. We're doing something. Okay. All right. Connection release. We send a FIN packet. Is there anyone here that has ever been surfing the internet or done something to close out your browser? Do it all the time. Do you always log off of your bank? No. Close my browser out. Because even if you do log off your bank, they tell you, please close your browser. So I just close my browser. Well, we don't always send the FIN. Okay? We'll talk more about that. But so the source is the FIN packet to the destination computer. The destination sends a FIN acknowledgement and then an acknowledgement back. He's saying, Brandon, I'm done talking to you. He says, okay, I acknowledge that. I don't want to talk to you anymore either. And I says, good, we're done. We hang up. It's kind of a 3-way either way. Or we can also send a reset to close it as well. Okay?
Isn't FIN Spanish for the end?
Yes, it is. Yes. Yep. Yes, it is. All right. It says all TCP packets are tracked with timers built into the protocol. Okay. I love some of these. A connection establishment. A session will not be established if it takes longer than 75 seconds. That's a long time. How about the FIN? Waiting for the FIN packet. The default value is 10 minutes. So basically, me and Brandon are talking, and I kind of just walk away. He's going to wait 10 minutes before he closes the conversation. Why would it be that? Why would we do that? Remember, years ago, we had very slow internet. And some things might have taken a long time to close out and stuff like that. So they'll just literally sit there forever. And how about satellite communications? I'm assuming some of those were really slow back then. I guess they're slow now. But so yeah, the default is 10 minutes. It's crazy. Okay. It says time, wait. This is default time for a timer is 2 minutes. To wait for a packet to arrive on the other end is 2 minutes. I don't know about you. I actually changed this on my own computer, so I put the new value in there. I'll show you. I don't wait 2 minutes for anything. Does anyone ever try to go to a website and literally waited 2 minutes? I'm thinking like 10 seconds. You're like, oh, that page ain't working. Let's go somewhere else. So you can change it just by going into the registry, editing the TCP time wait delay. I set mine down to 30. Show you where to do it right there. You can edit that. Okay. So also keep alive to check to see if the destination computer is alive. I love these. The computer may send a test packet every 2 hours. Wow. I'm going to wait 2 hours to see if you're still there. But, you know. I'm like, hello, are you still there? I'm going to wait 2 hours? No. All right. So it says, during development of the TCP in 1980s, it was like a 7-Eleven. There was no security built into it. It was not a priority. Since 1990, we realized, hey, we're idiots. We got a problem. We need to fix this. Okay. We had IP spoofing, connection hijacking, ICMP, SYN attack, and RIP attacks, which we're going to talk about now. Okay. All right, IP spoofing. It says a attacker sends packets to the victim or target with a false source address. Okay. Came from somewhere else. Okay. When I ran my ISP, so many times people would call me and says, Ken, someone's broke into my email. So what are you talking about? It says people replying back to me in the emails I didn't send them. That doesn't mean they broke into your email. I can send an email out with the source where it came from as Bill Gates if I felt like it. And if it doesn't get where it's supposed to go, where's it going to go? It's going to go back to Bill Gates. Okay. Cox, at least they did, I don't know if they still do. Cox had an ingenious way to work with spam. Okay. The way spam normally works is, say I'm a spammer, okay? I'm going to send an email to y'all. What I do is I send it to 6 million random addresses. But I put the source as an invalid address. So if I'm an ISP, I receive all these 6 million emails coming in. The ones that are valid, I deliver. The ones that are invalid, I try to send back. But what happens when I try to send them back to an invalid address? They reject and send it back to me again, so I end up having to, I manage the packet the first time it comes in. Then I send it back, so that's the second time. Then it rejects again, so I'm managing the same packet 3 times. What Cox did, it might still do, they did best guess. So if your name was Bob and an email came in for Bob, it got delivered to Bob. Well, if an email came in for Bob 1, and you were the closest one, guess what? You got Bob 1's email. Because they realize it's easier to deliver Bob 1 email to Bob than it is to reject it and have to manage that packet 3 times. So I don't know if they still do that, but they did for a while. Kind of a cool way of doing it. And most spam filtering now gets rid of it anyway, but it was different. All right. So the victim accepts the packet and sends a response back to the intended source. Okay. And this says the attacker must guess the proper sequence number to send the final ACT packet. With IP spoof, they're kind of trying to break into the conversation, which we'll talk more about. Okay. They may have a connection to your computer or not. And I think Kevin Mitnick was one of the first ones who did this. I can't remember exactly, but okay. All right. Here's this is Roy, the guy who used to work in my office, made me some graphics. His are probably better than mine. Okay. This is a not hijacked computer. Okay. We got a computer at the bottom, computer at the top, and the internet. So the red guy is talking to the internet, the black guy is talking to the internet, no problem. Okay. Here's a hijacked computer. Okay. And the middle guy says, I'm your gateway. The bottom one says, no, I'm really your gateway. Ignore the other guy. So basically, the black guy sends a packet to the red guy thinking he's the gateway, then he sends it out. It's like a man in the middle attack. Art poisoning works the same way. If you use a software called CAIN, C-A-I-N, you could go into IHOP, get on the internet, and just scan the available machines on the network, click on all of them and the gateway, and it says poison. What it'll do is it'll send all those laptops that are in IHOP, say, oh, that guy's not the gateway, I'm the gateway. Then all the packets will now be coming through you and then going out through the gateway. It's like 2 clicks of a button. So easy to do, and it's very scary. Now, there are some ways to make that better. A lot of stuff now, certificates don't work quite so well. So if you're in an IHOP and you're getting lots of certificate errors, that's normally a sign that someone's doing a man-in-the-middle attack, because it's not done correct. So if you ever Facebook, your email, whatever, and all of a sudden the certificates are all bad, someone's probably poisoned your network. But Cade's even nice. When you unpoison, it even undoes it all. It tells everybody the correct gateway and fixes the whole entire thing.
How do you get rid of it?
You don't.
You just turn it off?
Yeah, I mean, it's really, because at that point you won't even know who the real gateway is. So you're...
You just want to disconnect
Yeah.
that.
But what sucks about it is, with Kane, I can literally poison. Say you all had laptops, I can poison you all. And then it automatically grabs all your passwords. Automatically grabs your email passwords, your HTTP passwords. I mean, to an extent, not everything. But it can grab, there's another one called Fire Sheep out there, which grabs all your Facebook credentials. There's just so many things out there that use this kind of functionality that really screw people up. Scary stuff. Okay. So, it's a sequence guessing. A attacker sends a few connections to the victim to see how quickly the numbers are incrementing. I'm not an expert on making all this work, but they start incrementing at a certain speed. Different ones increment faster. So they're trying to figure out how fast they do it. Then they send one with a best guess sequence number, and hopefully it's, because they accept packets in a range. Remember I told you packets could come in out of order? So if I can get you to accept a packet in a range, send you one that's in that range that you're accepting, we now have a communication going. Then you can start talking to me. Okay? So they can guess the sequence number because the generator is using a global counter. Then it's incremented by a certain number. Okay? There's also something called source routing. Okay? It says source routing can specify the return path. It's like me telling you how to get home. Is that a good plan? If I told you how to get home and I-40 was broken, what would you do? You'd be stuck. Okay, with source routing packets, it's like they're forcing them to go a specific way. That's not what you want. You want them to be dynamic. They should be able to figure out the way to get home. Okay? It says the attacker looks for an intermediate computer router, then forwards packets to the target. Okay? Most new routers are automatically turned off. Okay? Here's the way to turn it off. I just put a command you can put in there. I think this is for Windows. Yeah, add a D-word value under TCP/IP parameters. Disable IP source routing, set it to 2. So, but pretty much nowadays, everything has the default turned off. Okay. All right, connection says it allows the connection to hijack an existing connection. They desynchronize a series of packets. It could be with a denial of service. It could be with all kinds of different stuff. Okay, it says extra packets sent to one of the victims force the victim to lose the packet to accept. Okay, lose which packet one to accept. Then if they can discard one, then you can start making them accept your packets. It's there's actually a lot of tools that will help you do this nowadays. I can't think of the name of some, but there's lots of them out there that will. Okay, ICMP, that's like denial of service. When I taught Cyber Patriot a year ago, or 2 ago, I talked about denial of service, and I showed the students how to do it. You can actually tell your computer to ping nonstop. I don't know if you know that. Let me show you. You can go in here, and I can do... Okay, I'm now sending a packet to my office computer and coming back again. Okay, and this is going to go forever. Well, those little high school kids go up there and get 50 command prompts open and doing this. So what they were doing is, it's like everyone calling my computer and is having to reply. But our computers are fast enough now where it can actually handle quite a few of them. Probably handle 1,000 even, but could it handle 1,000,000? That's the other question. You don't know. Okay, but that's what. Imagine this on a global scale with millions and millions of people setting this. So why is my TTL 127?
Because default's 128.
It's default 128. It got there and it's on its way back. It went down by 1 because it went through one machine. Okay. All right. So it says it's like the ping command. They use ICMP packets, and they use destination unreachable and time to live exceeded. Actually, that's also used in what's called trace route. I don't know if we have trace route on this one. Let's see if we do. Okay. All right. I ran trace route to my office machine. The only reason I'm running to my office machine instead of like Google is they block it going outside the school. So it won't go anywhere. So trace route, what it does, it sends the packet out with a time to live of 1. Okay. So say I'm sending a packet to Google. I send it out with a time to live of 1. It's the very first router. The router responds back, time to live exceeded, sends it back, and then that packet's gone. Then I record that router who sent me the reply. Then I send it out with a time to live of 2. It goes through the first router to the second router. That's now at 0, deletes the packet, replies back to me, time to live exceeded. That's how I get the second route. Then I go 3, 4, up to I think 30 it returns. And yeah, try that sometime from your house. Do a trace RT to Google or somebody. Because a lot of times you can read in the names where they're like St. Louis or Dallas or something like that. It's pretty amazing sometimes where they come from. Because it said you used to be to get from here to Charter Road, went through St. Louis and Dallas. And I was like, why over there and then down there to get there? But that's just the way my ISP was. Okay. Alright, so attackers transmitting spoof packets can successfully reset existing connections. You can kill them. Okay. Okay, SYN attack. Here we go. Says this is an issue with the 3-way handshake. Okay. Says receive a SYN request from A must keep track of the partially open connection. So if I call Brandon and he answers hello, how many times is he going to sit there and say hello? Well, he's going to do it for 75 seconds. So imagine Brandon sitting there answering phones and staying on the line for 75 seconds. So anyway, he's going to run out of phones or hands or something. Okay. When I worked for the ISP downtown, we actually bought out one that actually went bankrupt. So we got, it was Galstar Solutions out of Tulsa. We bought them because they went bankrupt. And the very last thing the guy did was he went in and changed all the secret shared keys for our dial-up system. He changed them all and saved them and turned the machines off. So naturally, we got the machines and nothing synchronized. We had nationwide dial-up that wouldn't work. So you can imagine all the clients started calling. And I still remember, it was like the very next day, office phones ringing nonstop, all of our cell phones were ringing nonstop. It was literally, all our voicemails were full. And we were just sitting there staring at our phones. I mean, we were overwhelmed. We had too many calls coming in to do anything. We couldn't fix it. There was nothing we could do because we had to go through AT&T, which was closed. That location was closed on the weekends. So we're like, crap. But with the SYN attack, we're sending so many SYN packets. So Brandon replies with the SYN attack, and I just don't answer him. He's like, hello? Are you there? He does that for 75 seconds. So that can get old. Okay? Says most systems are limited to keep track of only a small number of connections, which are good. But still, that's still taking up processing power and all that. It says attacker can overflow the list queue by sending more SYN requests than they can handle. So it's a SYN flood. We will be doing a project where you got to look for some of those. So just look for a whole bunch of SYN packets. And the destination sends SYN acts, but they don't go anywhere. No one ever, there's no final act. It's the SYN act, and then that's it. All right, RIP attacks, routing information protocol. Okay, routing information protocol is obviously for routing. The issue with the RIP is, I don't teach the routing class, so it might be a little off here, but if I remember right, RIP announces its entire routing table every 30 seconds. Is anyone taking routing?
Yeah, I'm taking it.
I'm pretty
It
sure
has
that's,
been a while.
I'm pretty sure that's what it is.
Seems like it tries to pass it around.
Right. So
You know,
it like tells every router it knows about
Yeah,
its
that's
entire
right.
routing table like every 30 seconds. So that's actually a lot of stuff. Okay. We obviously need it. Okay. But it's used without verification. Okay. ARP's the same way. That's why I can say, hi, I'm Bill Gates, and you're like, okay, how you doing, Bill? That's what RIP is. I can send out something with bogus data, and it just accepts it. Not the best plan. But again, back in the early days, we didn't care about security. We were running 7-Elevens at that point. We didn't care. Now all of a sudden we're trying to make banks and we can't. someone's going to jump in the middle of this conversation and say, what? Why is he talking about a 7-Eleven and a bank? Okay, no. All right. So, this is once it's modified, it can transmit all the packets. You imagine telling the router that you're somebody you're not supposed to be, or you're a different way to get there. You can just do all kinds of havoc. All right, securing it. Get a new one. Probably the best bet. It says, data in packets is not encrypted or authenticated. We know that. Okay, there are some ways around it. Packet sniffers can view them like Wireshark and stuff like that. They can actually view packets, which you guys will be doing. Okay, the attacker can send spoof packets from any computer. Okay, so a lot of issues. We must have some sort of method to simultaneously achieve success in this area. We've got to come up with something to fix all these issues. So how are we going to do that? All right, some methods to decrease vulnerabilities. Now, you notice it says decrease, because you're never going to get rid of them totally. It's impossible. It's one of those things, you know, when people say, oh, you can't, whatever, I'm on. Do you see the video of the guy, can't catch me riding the motorcycle down the highway? Was it in Canada or something? Someone see that? The guy was on a stolen motorcycle, had a helmet cam, was driving like 100 miles an hour down the highway, and he posted the video on the police department's website, you can't catch me. Well, they caught it. Because they were saying, man, he was, during rush hour, right between the cars, just zooming all in between them, and it was scary. But, you know, just tell them you can't catch me, that's all it takes. So, but TCP/IP, we decrease them, we can't get rid of them all totally. Okay, so we can get rid of some of the timers, lower them. Set a 2-minute wait, set a 30-second wait. Set a 75-second timeout, set it to something lower. So you can actually reduce some of the timers. When I very first started working with internet, I had a provider off of like 23rd and Broadway downtown. His name was Brandon, I forget his last name now, but he was very different. He had a Unix system that was the host, it was hosting all my stuff. But Brandon took nothing for defaults. Everything was different. Like he had a Linux system. He had no etc directory. He renamed it. Every single thing that was normal, his wasn't. Well, it was very hard to host a website with him, because instead of, you know, CGI bin or something, it's like, oh no, it's like dog2 or something. You're like, but it was very good for security. I mean, think way back when they actually knew enough to do all that. But, you know, anybody else, I don't think we could ever figure out a system. It was crazy, but, you know, don't use default stuff, okay? It says increase the number of simultaneous connections. So make it so you can answer more phone calls instead of just a few. That would help. Reduce the time limit to wait for the three-way handshake. We talked about that. Change the method to generate sequence numbers. You can do that. And also firewall rules. You can edit your firewall to block all kinds of stuff, okay? Like row state blocks incoming stuff, certain stuff. But they also block outgoing stuff. Can you think of any reason why you want to block outgoing stuff? Well, what if I got a virus on my machine? I wouldn't want my virus contacting outbound. So they only allow certain things to go out. It causes issues sometimes. If we contact them and they have to open the firewall and stuff like that. But all right. More methods. It says increase or avoid using the source address on authentication. Right? It says if an operator allows outside connections from trusted hosts, enable encryption, maybe with a VPN or something like that. Packets should be encrypted with a VPN or SSL. Okay? So you want to encrypt something is what you want. IPsec is a way of encrypting. Okay? It says the architecture of the IP protocol that protects IP traffic. A couple different modes, tunneling and transport mode, which I don't think they get into on here. But there's a lot of different protocols that work along with IPsec, like AH and ESP and all that they talk about down here. It's just different protocols used along with it to help encrypt. Okay? There's some more of them. Initially, Microsoft came out with one, PPTP, I think it was. I think it was point-to-point tunneling protocol. Because they had PPP and then PPTP, but they kind of didn't, it's still in use a little bit, but it really didn't come over as the standard. So now it's IPsec is the big one. Okay, provides encryption of user data for privacy, which is good. Okay, authentication of the integrity of the message. Prevents against replay attacks. I remember way back in 94, 95, when I was working on my master's degree, I was in a class taught by George Floyd, works at the OSF downtown. But he was showing us a video of one of the very first ATM robberies way back then. ATMs all worked via cell phone or phone lines. Someone had recorded the phone conversation and was just playing it back to the ATM. It was a video they caught him by someone who was standing out there with a brown paper bag just collecting the money coming out of the ATM. But it was kind of funny. But now, replay attacks aren't available anymore, so hopefully they're not, okay? It says, also the ability to device to negotiate security algorithms so they can actually change. Different algorithms, different keys, different stuff like that. 2 security models. There's tunnel and transport, which I kind of mentioned a little bit. Tunnel is, we know there's traffic going from here to here, but we don't know how much, we don't know when, we don't know what. Transport mode is, okay, I can see the amount of data going, I just can't see what it is. I can see the trucks going there, just don't know what's in them. Okay, so 2 different modes there. All right, that's the end of this chapter, and I want to talk about the assignment real quick. If I can discard, get out of there. Okay, let's talk about the assignment. Okay, your next assignment is already up there. You all have access to the Kali Linux system, I'm assuming? Hopefully you did, because you need it for an assignment, or else you did it at home. Okay? All right, using nmap on your Kali system. Hopefully everybody knows what nmap is now. It was an assignment. I mean, should be nothing new at this point. I want you to, using nmap, now you can do it on the vSphere system. Now if you do on your home system, you're going to have an issue because you got to do it inside that network. If you're going to bring your laptop here and plug it in, that's fine. Excuse me. Best bet, run the scan on your vSphere system, then email the results to yourself, and then just look at it. It only takes a couple minutes of it. On your nmap, use nmap on your Kali machine. Okay? Scan the Class C network starting with the network ID of 10.10.00. Don't contact me and say that's an invalid address. I know that's an invalid address. That's why I read that and you understand, hopefully. If not, figure it out. Okay? What I want to know, create a table of the machines. We're basically scanning the network. Nmap is network mapper. Okay? I don't know. Let me see if I can get it on here real quick. Come on. Let's see. Let me pause this for a second while I log into it. All right, we're recording again. Okay, I'm going up into Kali Linux here. It's loading. While that's loading, I'll finish talking about it, then I'll show you an example of it. Okay, what I want to know is, make me a table of the IP addresses you connected to, or you found, the operating systems, and the open ports. Now, I do not just get the output from nmap and turn it in. That's not what I want. I'd like you to just put a little bit of thought in. Now, for the open ports, tell me, are they a vulnerability or not? For instance, if it's a web server and they got port 80 open, is that a vulnerability? Well, it's a necessary evil. You're a web server. You have to have port 80 open. It's a slight vulnerability, but not a major one. Now, if you find telnet open, well, we can replace telnet with SSH, something like that, okay? Now, what you can do is list the machines and the IPs and the ports. Then at the very end, instead of listing the vulnerabilities all throughout the whole thing, just tell me all what the ports are at the very end. Because you're going to find, like, say, port 80 on many machines. So list it with each machine, but don't sit there and tell me about port 80 10 times. So list port 80, then at the very end in the appendix, that's where you can list port 80 as this. That kind of stuff. Okay. That will prevent you from having to do it too many times over. Okay. So I'm in here. Come on. There we go. Got that super secret password that Google only knows about. All right. Come on. You can do it. Okay. Now there's also a Windows version called ZenMap. No. ZenMap is the GUI for this, but there's also a Windows version of Nmap available. Yes. If you want to, you can use our labs upstairs and just run it. Now,
Is it WinMap?
it could be WinMap, it might be. So I'm going to do Nmap. I'm going to do 10.10.40.1 through 10.10.40. Say 100. That's not the ones you're doing. I'm just picking a different one. No address is open, seriously? Let's do 50. What? Okay. Okay, let's do. There's got to be some. What? Come on, find something. What's my IP address? Anyone even know?
It's scanning.
Yeah, but let's. I want to make sure. Let's see. Okay, 40.191. I'll just scan mine and make it quicker. $191. Okay, now, you need, is it dash A? There it is. Why does it show me the results? Come on now. What's the command? Hold on. Is it dash V? I can't remember the command. Small v maybe? Invalid. I thought you could do it that way. There we go. Well, oh, there's nothing open on my machine. Hold on. What is that other machine? 2. Oh, there we go. Okay. Well, my machine had nothing open. That's why. Okay, I'm looking at a machine here, and I'm seeing port 3389, port 80, port 445, 53, 135, all this kind of stuff. Does anyone have any clue what type of machine that could be?
Mail server?
It's actually a domain controller. ZenMap's not on these? Seriously? There's information gathering, network scanners. Wow, ZenMap's not on here. Okay, well this is going to finish in a minute, and it should tell. See, there's it's a DC1.rose.labs. You might have to look up the command. I think it's -O to get the operating system. Did I give it -O?
Yeah,
Yeah,
dash
that
capital
sounds
L,
right.
So let me put the -O in there.
dash capital L, I think.
Okay, oh, it was there. I saw it. Where'd it go? Okay, Windows 7, Vista, or 2008, or a phone. In that, there it is. Microsoft Windows 7 Professional. It's actually Windows Server SP1, I think, or SP2. So the -O gives you the operating system. But just try some of the different commands. Hopefully you looked into some of those on the last assignment. I'm giving you 2 weeks for this assignment. So what you do, just tell me the IP of this machine, maybe its name, what it is, and then the ports on it. And then, yeah. And you can actually output the results. Come on.
It's doing it.
Yeah.
There it's done.
Okay, there you go. I output the results to a file, then I viewed the file with CAT. So you can mail the file to yourself. This is a web browser and everything, so you can mail it to yourself. So write the results to a file, and then what I did there, you can view the results. So, okay, it's not that hard to figure out, but we're out of time again. So let me see. Let me shut this down real quick. Shut down and shut down. All right. So, yeah, for each open port, just tell me if the probable purpose and if it can be considered a vulnerability. I'm fine with you listing all the ports with the machines, and just give me a list at the end of what the different ports do. It's not hard to figure that out. Okay? You got 2 weeks for this one? Any questions? Everybody happy? We're out of class time, so y'all are free to go.
Did you say that the